All right, scientific notation. So, do you know what this number represents? It's actually the speed of light. So, the speed that the light waves from the sun, how fast they move to reach Earth. Do you recognize this number? Notice how the decimal is way over here. It's in kilograms. This is actually the mass of a dust particle. Of course, you don't normally write numbers like that. We like to use scientific notation because it's a shorter method to express those very, very large or very, very small numbers. Scientific notation is based on powers of the base number 10. So you'll always see numbers written similar to this. This first set of numbers, the 1.23, is known as the coefficient. This number is always greater than 1 but less than 10. The second part is the base. It's always base 10. And then you have some sort of exponent to help you know what the expanded version is. All right, so if we were going to write this number in scientific notation, huge number, right? So the first thing you do is you figure out the coefficient. So it's all of these numbers, 1.23. So you have the beginning part, 1.23 times, we know it's going to be a base of 10. We just need to know what the exponent is. So to figure out the exponent, you're going to have to count back however many zeros there are and numbers all the way up into the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is indeed 11, just as our correct answer suggests. You may also see it as 1.23e plus 11, such as if you're using like a scientific calculator, the calculator usually displays it in this form, or you may see it typed like this in PowerPoints and Word documents. All right, so another example, if we were going to write it this way, notice how the decimal is on the far left side. That is a really, really, really small number. So again, our coefficient is this. It has to be between 1 and 10, so it can't be 123, it can't be 12.3, it has to be 1.23. So it's going to be 1.23 times, we know it's going to be a base of 10, we need to know how many zeros there are. So we're going to count our decimal all the way over here until we get to over here. So you're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 again. However, since this represents a very small number and we're moving our decimal to the right, it's going to be a negative 11. Anytime you see these negative exponents, it's going to represent some sort of small decimal. All right, we got it correct. So now we're going to try these numbers. So you can pause the video, try them yourself, and then I'll go over the explanation. So let's look at number 1. You're going to change 0.0067 to scientific notation. So again, we need our coefficient. This is our coefficient. It can't be 67 because again, it has to be less than 10. So it has to be 6.7. Technically, to get to this coefficient, you'd have to move the decimal to the right 1, 2, 3 times. So it's going to be 6.7 times 10 to the third. And remember, this is technically representing a decimal number. We have moved the decimal to the right. It's going to be negative. Negative exponent anytime you have a decimal. Now number 2, you're going to write 3.0 times 10 to the 8th in a decimal notation. So we know that the number is going to be 3 something. We have a coefficient of 3 times 10 to the 8th. That tells you that you're going to move the decimal 8 times. And essentially, you're going to be adding 8 zeros. So the decimal's here. You're going to go 1, 2, 3, 4, 5, 6, 7, 8. Your decimal is going to end up there. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8. That should be your correct answer. Number 3, you're going to change 3,440 meters to scientific notation. So we have all of these numbers. we got to figure out our coefficient. So we know that we're going to be writing 3, 4, 4. However, it has to be between 1 and 10. So it's going to have to be 3.44 times 10 to something. So over here, our decimal is technically right over here, right? And we need to move it to right behind the 3. So we're going to have to move it 1, 2, 3 times. So it's going to be 10 to the third power. Oh, my negative sign disappeared up here. Yes, there we go. We got all the answers correct.